So let's kick off the chapter by discussing linear systems. A linear system of two equations with two variables is any system that can be written in the form ax plus by is equal to c, dx plus ey is equal to f. So we have two equations, each with two different variables, x and y, the same two variables in both equations. A, b, d, and e are the coefficients of our variables. And we see these expressions are equal to these numerical values being represented by these variables c and f. So we'll use both equations using the substitution and/or the elimination method, depending on the question, to find the value of the x and the y in these equations. And x will have the same value in both, as well as y. Now, a linear equation can include coefficients with a value of 0 as long as one variable is present in the equation. So 3x plus 2y is equal to 5 is a linear equation. We have our x and our y. Both have a coefficient here, 3 and 2, so that's fine. X plus 0y is equal to 7 is also fine. This would be x is equal to 7. So as long as you have one of the two variables present, then you're all set. Nonlinear systems, these are the types of expressions you won't see in this chapter. A linear equation can only have variables that each have an exponent equal to 1. So here we have 3 plus 2 is equal to 5. So we don't have at least one of our variables. So this would not be a linear system. X squared minus 2y is equal to 3. Here, our variable x has an exponent of 2, so this is not a linear system either. So throughout this chapter, our x's and y's will only have an exponent equal to 1. Now, 2x2 systems. A 2x2 system of equations is a set of two equations with two unknown variables. The solution to this system is the xy value that solves both equations. So for example, x plus y is equal to 5 and 2x minus 3y is equal to 10 is an example of a 2x2 system. We have two equations and they each have the same two variables, x and y. And the solution is when x is equal to 5 and y is equal to 0. In this case, 5 plus 0 is equal to 5, so the first equation checks out. And in the second equation, when x is 5, we get 2 times 5, which is 10, minus 3 times 0, our y. So we get 10 minus 0, which is equal to 10. So the x is equal to 5 and the y is equal to 0, winds up making both equations true, and thus 5, 0 is the xy value that solves this system. A solution to a system of equations is the point, the xy coordinate, where the two lines intersect. So we're working with lines, linear equations. The xy is the exact point that works for both lines. This is the point in space where both lines exist, and thus both linear equations work. So in essence, this is what you are finding by solving a 2x2 system. Now, not every 2x2 system has a solution. If a system of equations has two lines with the same slope but are not the same, then there is no solution. So if two lines have the same slope, but they cross the y-axis at two different points, then that will let you know that the lines do not cross. And if this is the case, then there will not be a solution. There's no xy point where they both exist. So when you have a 2x2 system, how do you know when this is the case? Well, the system of equations for parallel lines will produce a false statement during the substitution or elimination method. We'll take a look at the substitution and elimination methods in a second. But as you are using them, you'll wind up with a statement such as 0 is equal to 10, 2 is equal to 14, 5 is equal to -3, or something along those lines. When you wind up with a statement that is not true, that is a signal that there is no solution to the 2x2 system that you were given. Now, a different example is when there are infinite solutions. If a system of equations has two lines that are the same, then there are an infinite number of solutions. That is because at every single point, both lines exist because they are the same line. So when you have your 2x2 system, you'll know that you have infinite solutions when you wind up with a true statement, such as 0 is equal to 0, 10 is equal to 10, 7 is equal to 7. So remember, the system of equations for two identical lines will produce a true statement during the substitution or elimination method. So keep those in mind, and now we can jump into the substitution method. The substitution method is the process of solving one equation for one variable and then substituting this number or expression into the second equation to solve for the second variable. So let's start off with this example. Let's say we had the 2x2 system, y is equal to 3 and -4x plus 2y is equal to 9. We won't need to solve the first equation for a variable since it is the solution for one of our variables. So if you wanted to solve for x in the second equation, you would plug y is equal to 3 here. And now you'd be able to solve for x. Let's say you were given x is equal to 5, and the second equation is -4x plus 7y is equal to 15. You would plug 5 in for x, and then you would solve for y. So that is how you would use the substitution method to solve for the second variable when one of the equations provides you the value of the first variable. But let's now walk through an example of a 2x2 system in which both equations have two variables. So solve by substitution and check the answer. Equation A, x plus y is equal to 9. Equation B, 2x minus 3y is equal to -7. So we want to use the substitution method to solve for both x and y. So what we'll do is, we'll first use equation A to isolate x or y. This will give us an equation, not a numerical value, but we can then substitute that expression into equation B for x or y, whichever one we solve for, and then we can solve for the second variable. Now throughout this chapter, what I'll do is, if x and y have the same coefficient, whether it's 1 or another number, then I'll solve for x. I'll only solve for y first if y has a coefficient of 1 and x has a coefficient of another value. Because in that case, y would just be easier to find. Otherwise, I'll just solve for x and substitute x into equation B to solve for y. Just so you can complete the questions with the same process, so when I go over it, it's closer to what you did. Okay, remember you can solve equation A for either x or y, but I'll be solving for x when they both have the same coefficient. Okay, so let's go back to this question. So step 1, isolate x on the left side of equation A. So we'll take x plus y is equal to 9, and we'll isolate x. So that means we'll subtract y from both sides, giving us x is equal to -y plus 9. This is +9. So now we'll take this expression, and step 2, we'll substitute x into equation B here, giving us 2 times -y plus 9 minus 3y is equal to -7. And now we'll distribute this 2 to both terms inside the parentheses here, giving us 2 times -y, which is -2y, and 2 times +9 is +18, minus 3y is equal to -7. Since these variables have the same exponent, we can combine them. So -2y minus 3y is -5y. So we wind up with 18 minus 5y is equal to negative 7. And now we can solve for y. So we'll first subtract 18 from both sides to get rid of this constant, giving you negative 5y is equal to negative 7 minus 18 is equal to negative 25. So we get negative 5y is equal to negative 25. And now to get rid of this coefficient of negative 5, we'll divide both sides by negative 5, giving us y is equal to negative 25 divided by negative 5, which is 5. So now that we have a value for y, we can now substitute y into equation A. This was equation B. So step 4, we'll plug y into equation A. And then step 5, we'll solve for x. So x plus 5 is equal to 9. So we'll subtract 5 from both sides, giving us x is equal to 9 minus 5, which is 4. So using the substitution method, we find that x is equal to 4 and y is equal to 5. So that is the solution to the 2x2 system. And step 6, to check the answer, you want to plug the xy, 4, 5, into the original equations to confirm that this is true. So when you plug x is equal to 4 and y is equal to 5 into equation A, we get 4 plus 5 is equal to 9. 9 is equal to 9 confirms that these are the xy values for equation A. And now for equation B, 2x minus 3y is equal to negative 7. 2 times 4 is equal to 8. Negative 3 times 5 is negative 15. 8 minus 15 is equal to negative 7. Negative 7 is equal to negative 7 confirms that x is equal to 4 and y is equal to 5 for equation B as well. So that is how you go about solving a system with the substitution method. Let's now have you complete a few practice questions. Solve by substitution and check the answer. Question number 1. Equation A, negative 3x minus 3y is equal to 3. And equation B, 5x plus y is equal to negative 17. Question number 2, equation A, 2x plus y is equal to 20. Equation B, 6x minus 5y is equal to 12. Question number 3, equation A, negative 2x plus 6y is equal to 6. In equation B, negative 7x plus 8y is equal to negative 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, isolate x on the left side of equation A. So equation A, we have negative 3x minus 3y is equal to 3. So we'll isolate x. So we'll start off by adding 3y to both sides, giving us negative 3x is equal to 3y plus 3. And now to get rid of this coefficient of negative 3, we'll divide both sides by negative 3, giving us x is equal to 3y divided by negative 3 would give us negative y, since the 3's would cancel out. Positive 3 divided by negative 3 is negative 1. So we get x is equal to negative y minus 1. And now we can take this expression and substitute x into equation B here. So we get 5 times negative y minus 1 plus y is equal to negative 17. You now want to distribute this 5 to both terms inside the parentheses, giving us 5 times negative y, which is negative 5y, and 5 times negative 1 is negative 5, plus y is equal to negative 17. You want to combine the like terms. Negative 5y plus y would give you negative 4y. So we wind up with negative 5 minus 4y is equal to negative 17. And we can solve for y now. So we'll add 5 to both sides to get rid of the negative 5. So we get negative 4y is equal to negative 17 plus 5, which is negative 12. And now to get rid of the coefficient negative 4, we divide both sides by negative 4, giving you y is equal to negative 12 divided by negative 4, which is positive 3. So now that we've solved for y, step 4, we want to substitute y into the other equation, equation A. So we'll plug it in here, and then step 5, we'll solve for x, giving us negative 3x minus 3 times 3 is equal to 3. Negative 3 times 3 is equal to negative 9. We'll now add 9 to both sides to get rid of negative 9 on this side, giving us negative 3x is equal to 3 plus 9, which is 12. In order to get rid of the coefficient, negative 3, we'll divide both sides by negative 3, giving us x is equal to 12 divided by negative 3, which is negative 4. So the solution is x is negative 4 and y is positive 3. In step 6, we can check the answer by plugging the xy, negative 4, 3, into the original equations. When we do so, we get negative 3 times negative 4 is 12, minus 3 times 3, which is 9. 12 minus 9 is equal to 3, and that's equal to 3. So for equation A, x is equal to negative 4 and y is equal to 3 checks out. And for equation B, 5x plus y is equal to negative 17. 5 times negative 4 is negative 20, plus 3. Negative 20 plus 3 is negative 17. So this confirms that for equation B, x is equal to negative 4 and y is equal to 3 as well. So that is the solution to question number 1. Let's now have a look at question number 2. We had equation A is 2x plus y is equal to 20, and equation B is 6x minus 5y is equal to 12. Since the coefficient of y here is 1, it's easier to solve equation A for y. So we'll isolate y on the left side of equation A for step 1. So we'll subtract 2x from both sides, giving us y is equal to negative 2x plus 20. And now step 2, we'll substitute y into equation B here. And then step 3, we'll solve for x. When we do so, we get 6x minus 5y, which is minus 5 times negative 2x plus 20 is equal to 12. When we distribute the negative 5, we get negative 5 times negative 2x, which is positive 10x. Negative 5 times 20 is negative 100, and that's equal to 12. We can combine the like terms. 6x plus 10x would give us 16x. Minus 100 is equal to 12. Now we'll add 100 to both sides, giving us 16x is equal to 12 plus 100, which is 112. And now to solve for x, we want to get rid of this coefficient of 16. So we'll divide both sides by 16. So that would give us x is equal to 112 divided by 16, which is 7. And now that we've solved for x, we can now solve for y. So we'll substitute x into equation A here. And then step 5, we'll solve for y. So 2 times 7 is equal to 14. Plus y is equal to 20. And to isolate y, we'll subtract 14 from both sides, giving us y is equal to 20 minus 14, which is equal to 6. So for question number 2, we get x is equal to 7 and y is equal to 6. And to check this answer, step 6, we could plug it into both of the original equations to confirm that x does equal 7 and y does equal 6 for both. So for equation A, 2 times 7 is 14, plus 6 would give you 20 is equal to 20. And for equation B, 6 times 7 is equal to 42, minus 5 times 6, which is equal to negative 30. 42 minus 30 is equal to 12, thus confirming that x is equal to 7 and y is equal to 6 for both equations. In question number 3, we were given equation A, negative 2x plus 6y is equal to 6, and equation B, negative 7x plus 8y is equal to negative 5. So we'll start with equation A, and we'll isolate x on the left side. So in order to do so, we'll subtract 6y from both sides, giving us negative 2x is equal to negative 6y plus 6. To get rid of the coefficient, negative 2, we'll divide both sides by negative 2, giving us x is equal to negative 6y divided by negative 2 would be 3y. Positive 6 divided by negative 2 would be negative 3. So we get x is equal to 3y minus 3. And now step 2, we want to substitute this expression for x into equation B here. And then step 3, we can then solve for y, giving us negative 7 times x, which is negative 7 times 3y minus 3, plus 8y is equal to negative 5. Negative 7 times 3y would be equal to negative 21y. And negative 7 times negative 3 would be positive 21. Plus 8y is equal to negative 5. We can combine the like terms, negative 21y and positive 8y, which would give us negative 13y. And now we can solve for y. So we'll subtract 21 from both sides, giving us negative 13y is equal to negative 5 minus 21, which is negative 26. And now to solve for y, we'll divide both sides by negative 13. Giving us y is equal to negative 26 divided by negative 13, which is equal to 2. So now that we have a value for y, we can substitute y into equation A and then solve for x, giving us negative 2x plus 6 times 2, which is equal to 6. 6 times 2 is equal to 12. So we'll subtract 12 from both sides to get rid of positive 12 on this side, leaving us with negative 2x is equal to 6 minus 12, which is negative 6. In order to get rid of this coefficient of negative 2, we'll divide both sides by negative 2. When we do so, we get x is equal to negative 6 divided by negative 2, which is positive 3. So the solution to question number 3 is x is equal to 3 and y is equal to 2. In step 6, we can check the answer by plugging the xy into the original equations. When we do so, we get negative 2 times 3, which is negative 6, plus 6 times 2, which is 12. Negative 6 plus 12 is equal to positive 6, which is equal to 6, thus confirming that x is equal to 3 and y is equal to 2 are the correct values for equation A. And for equation B, negative 7 times 3 is negative 21, plus 8 times 2, which is positive 16. Negative 21 plus 16 is equal to negative 5, and that's equal to negative 5. Thus confirming that x is equal to 3 and y is equal to 2 is the solution to this 2 by 2 system.